तो अब गॉस लॉ की दूसरी एप्लीकेशन करते हैं, which is electric field due to a thin sheet of charge. तो एक infinitely long thin sheet of charge लेते हैं which extends up to infinity, और इनके आसपास हम दो पॉइंट्स डिसाइड करते हैं, लेफ्ट एंड राइट साइड. लेट्स से certain distance r, both the sides. Then we join the points around, which is like a cylinder. Now we decide the direction of surface area and electric field. This phase ds acts on the surface और electric field भी इधर ही act कर रही है. Opposite phase ds and e acts along the same line. अगर हम curved surface की बात करें तो ds acts along the line surface, but electric field is perpendicular to it. So total flux pi is equal to phi1 plus phi2 plus phi3, which means phi1, let's say first surface, this curved surface is second, other one is third surface. So we will write E ds1 cos 0 degree first surface plus E ds2 cos 90 degree plus E ds3 cos 0 degree, which means phi would be cos 0 is 1, so this is es plus cos 90 0 plus es is equal to 2es1. और गॉस लॉ से हम क्या जानते हैं, ऑल्सो phi is equal to q upon epsilon naught, and if we take surface charge density, then sigma is equal to q upon surface area. Therefore q becomes sigma into s, and so we write sigma into s upon epsilon naught, equation number 2. So from equation 1 and 2 we get, तो क्या मिलता है हमें, 2es is equal to sigma s upon epsilon naught, which means s is cancelled, and therefore we get electric field as sigma upon epsilon naught, which means distance r is missing. So constant field we are getting due to a thin sheet of charge, right? Now if we take two sheets together, then it would be little different. How? Let us see. For two parallel sheets or thin sheets, then sheets are like this, both are charged. So if one is positive, other one would be negative. And if we find the field due to this positive, let's say at this point, electric field would be away from this point, let's say E1. At the same point P, due to negative, it will be inward, E2. So this E1 and E2, Likewise, at this point, due to negative, it will be inward. Due to positive, it will be away. So this is E1 and this is E2. At the center, due to positive, away from the point E1, and due to negative, towards the point. So this is E2. So what we find? We see that this will be equal and opposite, so 0. Here equal and opposite, so 0, because value will be sigma by epsilon naught only. But here sigma by epsilon naught plus sigma by epsilon naught. So it is 2 sigma upon epsilon naught. Inside in between the sheets, it will be 2 sigma divided by epsilon naught. And this formula we are using for capacitor also, which means capacitor, right? Now let us go for the third application. Although this is not part of CBSE syllabus now, but easiest of all, so we can do that. Third application of Gauss law. Which is what? Electric field due to a sphere. Electric field due to a sphere. There are 3 cases in this. It is outside the sphere. When we talk about a sphere, let's say this is a sphere having certain radius capital R, and we are at a point this. Again, we draw Gaussian surface around it, and we want a field over here at point P. So ds acts like this. Electric field would be also act along the same line. So electric flux we write E ds cos theta, so it will be cos 0. Cos 0 is 1, so this is E s 1, and we know phi is q upon epsilon naught also 2. So if you equate, what we get? Es is equal to q upon epsilon naught. Therefore, E becomes q upon epsilon naught into S. And surface area, if we write, what we get? This surface area would be 4 pi r square. So it becomes q upon 4 pi epsilon naught r square. So this is the answer. Now, if you go for second case, which is on the surface. So on the surface means this is R, and this small r would be also same. So when we talk about this, which is the ds and field, both are acting along the same line. So ds and E, and thus flux is E ds cos 0. So it is Es, and Gauss law also tells us that this phi is equal to q by epsilon naught. Now we are on the surface. So if we take charge density, q will be sigma s, and s would be what? 4 pi r square. This time capital R square divided by epsilon naught 2. So from 1 and 2, what we get? Es is equal to sigma into 4 pi r square divided by epsilon naught. Now, if we talk about this S will be also 4 pi r square only. So E into 4 pi r square is equal to sigma into 4 pi r square divided by epsilon naught. So 4 pi r square 1. Therefore, E is equal to sigma upon epsilon naught, which is constant field. There is no variation. So far, third case is concerned on the surface, inside the sphere. When we talk about inside the sphere, because Q is not possible inside the sphere. On the surface, charge is fine, but inside any sphere, charge does not exist, and therefore field is also not existing. And that way, we take electric field inside 0. If we club them together and draw a graph, variation for all, then graph becomes graph is like this. This is electric field and this is R. This center to this value electric field is constant, means this is for the second case. Second case, in that electric field is sigma by epsilon naught. So no variation with the distance up to this surface of this sphere. When we move beyond, which is first case, then 1 upon r square, so parabola kind. And inside, if you go, it's 0. So it represents the graph of E versus R for all the sphere. Thank you so much.